Klipper firmware is considered to be a speed and quality boost. Features like input shaping and pressure advance should level up every 3D printer. But how much can you really profit from using Klipper? I'll give you the answer comparing 4 low-end bed slingers before and after Klipper installation. Faster printing is one of the big things in FDM at the moment. Manufacturers like Focus and Anker advertise their newest bed slingers being 5 to 6 times faster, which is, in my opinion, quite misleading. What really matters are the gains in actual print time. Klipper might be one of the most advanced firmwares for FDM printing at the moment. Using input shaping along with higher accelerations as well as pressure advance should improve the print time significantly without sacrificing print quality. Is it really worth the efforts? I checked it out with these 4 cheap bed slingers. The printers for this video were provided by Geekbuying, BQ, Focus and Kingroon. The BQB1, the Artillery Hornet and the Focus Odin 5F3 can be considered as quite typical in the 3 clones. The Kingroon KP3S is a cheap and interesting smaller scale printer I wanted to include into this comparison. Unpackaging and building these printers was quick and easy, except for the BQB1. There is quite a bit more to assemble and to adjust correctly, which could cause potential problems for absolute beginners. Concerning the spares and accessory you get with those printers, not worth mentioning the differences. Everything is provided in order to get started with these machines. But instead of using the reskinned or old Cura versions provided with the printers, I went for an easier and better way. All of them are i3 style printers. Just like the Prusa Mark III, which comes with thoroughly optimized profiles in Prusa Slicer. As a baseline for the stock Marlin performance, I simply used the 0.2mm quality preset of the Mark III, which works perfectly on almost every bed slinger. The only settings that need to be adjusted are concerning some basics for the machine itself, extrusion and retracts, as well as the automatic cooling settings. Setting a viable max volumetric speed value is very helpful as it automatically limits the printing speeds according to the performance of your extrusion system. In order to check if there is any unexpected behavior on these printers, I did a quick flow rate test on PLA Plus with Stefan's helpful tool. The KP3S, BQB1 and the Artillery Hornet perform at around E3D V6 level. The Focus Odin with its Volcano clone and custom extruder performs at around 35% superior to the other printers. So no surprises concerning extrusion. For the automated cooling settings, I printed 2 test models iteratively on each printer in order to determine the minimum layer time and the minimum print speed for each printer. The circular cooling concept of the BQB1 works very well, followed by the 4010 setup of the Focus Odin. The air duct attached to the 5015 fan of the KP3S would profit from some optimization concerning the air duct design. The Artillery Hornet though is underperforming. It might have 2 4010 fans, but the airflow is dispersed way too much here. I did a bunch of different test prints on the stock printers and documented the print times. All in all, it's a good mix for the comparison before and after installing Klipper, as there is different emphasis on the prints, like acceleration, speed or cooling performance. All prints came out well, except for the Kingroon KP3S. I was not able to get rid of the stringing and there were some visible extrusion flaws. End of the story, the hot end was not properly assembled, leaving a gap between nozzle and heat break. Therefore, the PTFE inliner of the heat break got damaged. I didn't receive a spare part in time, but I went on with the tests on the KP3S. But now, let's finally check out the Klipper boost on our low-end bed slingers. The Klipper documentation is very well done and also very detailed. There is a ton of background information, which is great on the one hand, but might scare off some users because of the amount of text to read and understand. Some of the best Klipper tutorials you can check out additionally are made by Teaching Tech and 3D Printer Beginner. Basically, the procedure is the same for every 3D printer or mainboard. If you follow Klipper's official documentation step by step, you'll definitely succeed. I'll show you why it is worth it, even for cheap low-end bed slingers. Input shaping will help to multiply accelerations and speeds, at the same or even better print quality. Pressure advance is a measure in order to optimize the filament flow, enabling quality printing at those higher speeds. Last but not least, configuring firmware settings in Klipper is very convenient in comparison to Marlin. You simply edit a text file and restart the firmware. No recompiling and reflashing. Though, in order to take full advantage of input shaping and pressure advance, you need to do measurements and calibrations, as the settings need to match to the used hardware setup. For input shaping, I used the automated measuring, as it is more precise, but it requires additional hardware such as an accelerometer and additional wiring. Also very important to know, Klipper does not support many displays natively that connect to the printer's mainboard. The Klipper screen add-on supporting displays directly connected to Raspberry Pi is an alternative you can check out. The results and calculations of measuring resonances and input shaping gives in some extent an evaluation of your printer's setup. This concerns the construction itself, as well as the build quality, the weights of the moved masses in X and Y, as well as the belt tensions. As a result, you get recommendations for the maximum accelerations for each direction, as well as for the settings of the frequencies for the shapers. Acceleration should be validated afterwards during a test print procedure, which increases the acceleration dependency of the layer height. By judging the resulting ringing and smoothing, this helps you to find out the max acceleration in order to not lose print quality. Feasible accelerations for those Cartesian printers range from around 3000 mm per second square up to around 4000 mm per second square. Using nowadays marketing terms like from focus and anchor, this would be 6 to 8 times faster in comparison to the 500 mm per second squared of most Ender 3 clones. This will never, ever transfer into the real gains in print times. We'll talk about that later. For all printers, I also tweaked the extruder and set movement settings. Thanks to pressure advance, which is retracting all the time anyways, retract length can be lowered to somewhere from 1 to 3 mm, depending on Bowden or direct setup. Also, retraction speeds and accelerations can generally be set way higher than the stock values. A fast and safe value for PLA somewhere between 70 and 100 mm per second for retract speed and around 3000 to 5000 mm per second squared for retract acceleration. Thanks to pressure advance and input shaping, we can also go with decisively higher speeds in our print settings. This time I used the 0.2 mm speed system preset for the Mark III as a baseline. I did some test prints and in the end I increased the speeds up to 100% depending on the feature. We are still limited by cooling and the max volumetric speed of the extrusion system because Klipper won't improve the hardware magically. I repeated the set of prints I did before on stock firmware, but now with all the Klipper features enabled and with the improved settings in firmware and slicing. The quality is at least as good as on Marlin and the slower Prusa 0.2 mm quality preset. But how much faster is Klipper concerning print times, really? Klipper boosts these printers, being cheap bad slingers, up to 2 times faster. Which is definitely a tiny bit mind-blowing, but far away from the marketing of Focus and Anchor. Smaller prints like a Benji for example, which are cooling limited due to short layer times, do not profit that much from Klipper, because again, it doesn't magically boost the cooling performance. Though it drops the print time significantly, all the way ranging from at least saving 30% up to 50% of the overall print times. This can make a huge difference. This might help for your daily routines, your progress in projects, or your 3D printing business might become more profitable as you could double the throughput of your machines. So, is it worth it? From my point of view, definitely, because I'm impatient and I love to go fast. But I also have quite some experiences with Klipper and the necessary calibration procedures. Furthermore, I mostly don't really use or need displays on my 3D printers, as I always have a smartphone or a PC nearby. In the end, Klipper installation and calibration is quite simple, but it can take time and a lot of things to learn for beginners. On the other hand, reading, trying, understanding and succeeding with new topics is fun in the end, right? However, there is good news for the future. The commercialization of Klipper for the mainstream market has started and we'll see Klipper out of the box on more and more printers in the future. The only thing that concerns me a bit, even more than Marlin, Klipper needs well-tuned settings for firmware and slicing. After testing some bad slingers the last months, I have to say, that's not really the parade discipline of cheap printer manufacturers. But we'll see. Right here on 24/7 Printing. Oh, and don't forget to leave a like and comment and blah blah blah. You know what to do.